Good morning, everybody. This is Cassie Stumo. I am the marketing specialist here at EAC. Thank you for joining us today for our webinar. We'll start off today with an intro of EAC, and then PTC's technical specialist, Paul Dye, will show us how to use this technology for analysis early on in the design phases for things like quicker design cycles, less prototypes, and more accurate simulations. Everyone gets a recording of the session pending any technical difficulties. There will be a short survey that appears once the webinar is over, so hang tight once we're done and drop your questions in the queue along the way, and we'll answer them after the presentation. So first things first, I'll tell you a little bit about who we are. At EAC, our mission is to transform the way companies design, manufacture, connect to, and service their products. We're more than just a value-added reseller for PTC. We've partnered with them for over 20 years. We have experts in 22 areas of product development. We're located all over the U.S. with our headquarters in Minneapolis, Minnesota. We offer our customers everything they need for product development, from CAD and simulation software for the full product design process, software for managing service documentation, and software for managing product data. We assist with design and engineering projects and offer webinars and PTC certified training courses for continuous learning. We also implement the industrial Internet of Things and augmented reality into business strategies to jumpstart initiatives around digital transformation and connecting all things in your company. We also offer our customers Form Labs. It's a desktop SLA printer. Packages start as low as $3,499. So anyway, we try to make sure you remember that EAC is the company you need to partner with to get all the technology you need at the forefront to make your team successful. I will go ahead and hand things over to Paul so he can get started.
All right. Thank you, Cassie. And again, my name is Paul Dye, and I am an application engineer with PTC. I work with all things Creo, and of course today we're going to be going over Creo Simulation Live. And so to start off, we'll take you through some of the challenges that we see around simulation out in the industry today, or even some of the ones you might see in your systems currently. And then we'll take us through our solution to a lot of these challenges with Creo Simulation Live, or CSL as we often call it, along with many other capabilities that we have for this tool. So after that, we'll also go through a demonstration of the extension so we can see what the tool looks like in the context of Creo. And then finally, we'll discuss how you can move forward with Creo Simulation Live and some of the real value that it can provide. So first of all, analysis is generally seen as too time-consuming to utilize properly in the early stages of design. It's because our models are always in a constant state of change, and we simply don't have the time to run the analysis. That leads our designers and our engineers to rely on their experience or just their intuition when they're making very critical design decisions. That means that the design decisions that we are making aren't really backed by anything but simply just intelligent guesses. And any analysis that we do takes place only in the late stage portion of the design, and errors that we have oftentimes aren't even caught until then. So these errors can often be attributed to our inability to support any analysis-led design. And all of this really leads to reliance on things like physical prototypes and testing to validate the performance of our designs. Because we do need a way to validate the actual decisions that we're making, which really leads to having two separate worlds in that process. So one in the beginning for design and iterations in the early stages, and then another world for analysis and validation in the later stages of design. So what we're looking to do is to break down the wall between those two different worlds and work in one unified modeling and analysis environment. And our way of doing this in the world of Creo is with our Simulation Live extension. So what we've done is partner with ANSYS, the leader in engineering simulation for over 48 years, and embedded their Discovery Live simulation engine directly into Creo Parametric. So the Discovery Live engine uses a powerful linear solver. It gives us the ability to perform static analysis on both the part and the assembly level. So we can go through and rapidly start to define and perform things like structural, thermal, and modal forms of analysis. So, and all of this at the same time is working in a meshless environment. So because of the way that the engine's been built out, we're actually removing the need to manually go through and create a mesh in the model, saving us a ton of time. And also throughout that process, we have the ability to get instantaneous results from the analysis. That includes when we make changes to the part, changes to material used, or even changes to the analysis definition itself. And so this process, the entire thing is running seamlessly right in the modeling environment. And it's extremely easy to access. All we need to do is click up on our Simulation Live tab at the top of the screen, and then we can start to go through and define the parameters for what our study happens to be. And then everything that we define appears on the left-hand side of our screen in the simulation tree, so you can very quickly go back and redefine anything that we might need to alter later on once we go through some of these studies. We're also able to run multiple different simulations per model, which can then be saved to the model. And then in that process, only one simulation is going to be active at any one time. And then we have the ability to go through and toggle between different simulations right from the simulation tree. Let's take a closer look into the models themselves and how the system runs its analysis. So when we're running the analysis on assemblies, they're all defined as bonded assemblies. That means that any connectors or any touching surfaces are going to be treated as bonded, and the analysis is then run on that bonded model. And the solver that we're using is running continuously in the background. So any changes that we make to our designs, they're going to automatically update in the results for us. Then we can also take analysis created over in our Creo Simulate module, which is a different, more high accuracy, high fidelity FEA analysis tool in Creo. We can also leverage that analysis and features over in Creo Simulation Live, or CSL. And as we do with many of our tools in Creo, we've also worked CSL to be integrated in seamlessly with some of our other extensions. So for example, here we have the Design Exploration extension, or DEX. And this is our tool for trying out new design ideas, exploring new iterations within existing designs, and then being able to keep track of the decision points along the way. And so throughout that process, you don't make any risk or any changes to the original design, or even have to commit to any changes. And so this is something that we'll see over the course of our demonstration today, and this is seamlessly integrated in with our Simulation Live extension. And looking at the results that we're getting, they're very interactive. So once we're in the analysis, we have display options available to us that we can alter for whatever our use case happens to be. So depending on the mode of analysis, we have different options for visualizing our results. So for example, in a structural study, we can display deformation, von Mises stresses, principal stresses, and other values around that. The model visualization itself can also be altered to view different surfaces, different ISO surfaces with this color gradients, and also minimum and maximum values. And then to really understand the results, we can animate the model to very clearly display that visualization. Continuing on here with how we can view our analysis results, we have an analysis legend located in the top right to help the user interrogate the model. So with this, we're able to change the scale of the legend to best fit your particular study, and also change the units based on our needs. We have the ability to query on the model itself to pick out specific areas or different surfaces that we want to get more information on. And so that includes the ability to place probes on the model, show how specific values are changing as we make changes to the study. We can then, throughout that process, highlight and annotate the minimum and maximum areas in the model, further give us some insight. And then once we're finished, we then can export our results to an HTML report to use off however we might need to downstream. So that was a brief introduction and overview of what we're working around Creo Simulation Live, or CSL. And now we can take us through an example and what this process would look like in the context of Creo. Okay, so up on the screen here, we have the data set that we're going to be working with today. And so this is actually one of our customers with PTC that we've worked extensively with, is Polaris. And this is actually the iron chassis off of one of their snowmobile assemblies. So what we'll do first is we'll go into just the part level to see how this works and how this whole process is laid out. And then we'll take a step back later on, and then we'll see how this process still works as we move back and increase that complexity back on the assembly level as well. So to start, we'll first begin by giving our part some materials. In this case for mine, we're going to give it an aluminum alloy, and then we'll go through and dive right into our simulation. In this case, it's going to be a structural study. And for a structural study, we'll first go through and apply whatever constraints that we want to look at. So for my part here, I'm going to look at the lower bore and have that be fixed in place. After this, we'll apply whatever loads that we want to study. In this case, I want to apply a force load upon some of these different inner surfaces. And one thing to notice throughout this entire process is with a standard FEA tool, you would have to take a part or a feature like this and you would have to completely defeature it. So you'd have to get rid of any small holes or rounds or even any interferences happening on the model, and that can be a very time-consuming process. But when working with Creo Simulation Live, we don't have to worry about any of that. All we need to do is apply different constraints, apply whatever loads we want to study, and then leave everything with the model exactly how it is. And that's the entire process of laying it out. And then once we have it, we can just simply click to simulate and get our results. And there we have it. That's how long it takes to run through and get the results back. So there's no waiting around and basically having the system run until you can finally get the results back. As soon as you click it, you can go through and start to get this type of information on the model. See the deformation, see that deformation right on the model itself. And if you wanted to see a bit more true to life, less exaggerated form of that, you could also zoom in and see that as well. So obviously with a structural study, deformation is going to be important, but so are the different stress values that we're seeing. So here, let's take a closer look into the von Mises stresses and see if we have any areas on our model that might be cause for concern. Here we have that maximum value for von Mises stress being highlighted on the model. So you can query on that and get more information into that specific area. And so to do that, we're going to apply a simulation probe. So this allows us to go through and see for whatever value that we're looking at, see with this surface what the maximum von Mises stresses are happening here. In this case, we're seeing around 55.7 megapascals of von Mises stress. So this is at the point where we would simply go through and build out features, make changes to lower down that stress value. So here we can use our flexible modeling tool. We can move out this wall thickness perhaps by 1 inch and then see how all that adjacent geometry is still going to update for that change. So we can again make that change, check off, and have the analysis run through again. And there we go. The analysis results are already updated. So it's not something that we have to wait around to get those results back. And that's really the main idea here is whenever I make a change to one of my features, is that having an effect on the values that I'm concerned with? So if I increase the radius, is that going to have an effect on the stress values that we're seeing? And we don't have to wait. We can see exactly whenever I make that change, what the stress value is going to be. All right, and so that's our first look into one of these examples. Obviously, it's very quick and very easy to run through one of those. What I'd also like to look at here is how this works in with some of our other extensions, especially here and with the design exploration extension. So we looked at a brief example of this in the PowerPoint. This is our tool for going through and basically trying out new ideas, new different iterations, and throughout that process, we're able to save them off as checkpoints that we can refer back to, branch off of, and try out all different iterations. And then at the end, save it off as just one session, one file. So it's not all these different assemblies and parts that we have to sift through to look at the different iterations. We have that all within one concise location. So obviously here, we're starting with a pre-modified version, and then I can go through and start to make whatever changes I need to. So from looking at our initial study around the stress values, we obviously see that some of these stresses are being centralized along this center bore here. So I'm going to apply a point probe to start to see if we can maybe spread out those stress values along the face of this part a little bit better. And again, this isn't anything different than what we would be doing in standard Creo, standard CAD work. It's just doing all the different features that you'd want to do, doing extrudes, could be sweeps, could be making rounds, whatever happens to be in the part, just do exactly the modeling changes that you would be normally doing. And then as we do that, we then again can have all those analysis results right up on the screen for us to look at. So obviously there, our stress value is going to change. In this case, it actually increased by a little bit, but that's good in our case because it means that the stress values are being spread out along the face of this part a bit better. So once we have that change, we could then save that off as another iteration and make that a checkpoint in our checkpoint tree. You give it a name for whatever we would like there. In this case, I'll just save it off as checkpoint 2. And that's the process. Then we could keep moving, keep making changes to however many different iterations that we want to look at there. In my case, I'm pretty happy with the part that we came in with, so I'm not going to save off that design session for now. So again, that's a good look at what we're looking at here on the part level. So again, the next question is, whenever we start to increase that complexity by working more on the assembly level, how is Creo Simulation Live and that process going to work with that? So it starts off in a pretty similar manner. So we'll still go through and start into our simulation by applying our constraints and our loads. So in the back here, you can see we have some fixtures laid out where perhaps this chassis body is going to be welded down. And then in the front, we might want to, for the chassis, might want to look at more of a shaking force that we have here. So on the right, we could have a downward force on one of these faces. And then on the left side, we would have a resulting upward force that we need to study. And again, this model right here, this whole assembly obviously has a lot more components happening, a lot more small holes and rounds and different interferences on this model that obviously with a standard FEA tool would give it a lot of problems. And it could take days and days to even get this model to the point where it meshes correctly to even get into the point where we could run the analysis. But with Creo Simulation Live, we're completely skipping the need to go through that step of the process. And then all we need to do is simply go up to the top and click to run our simulation. And there we have it. So as fast as we did on the part level, we're able to get results back on the full assembly level as well. So this is something that with this analysis tool typically would take me hours or again, even days to actually get this analysis to run through in the first place. But with this, we simply click and by the time we look back at the model, we already have the results. And that's when we can go through and start to really analyze, really look into whatever values and different things that you want to get more information on here. So in my case here, again, with something like this chassis body, obviously I'm worried about deformation values that we're seeing. So again, that gives us the ability here to go through, look at the areas we're concerned with, inquire on the values that we need to get more information on. So here, of course, I'm looking at deformation. So we're seeing on this top face how much deformation we're seeing. So right here, we're getting around 1 millimeter of deformation. And what we can actually go through and see here is over in my model tree, I have some parts suppressed. I have a support canopy that actually attaches to this chassis body. So we can move back out of insert mode here, add these different parts back into the assembly and see how the analysis results update for that change. And there we go. You can see as soon as we add in those parts, you can see the deformation value updates from 1 millimeter down to 0.34 millimeters, and we don't wait around for those results at all. As soon as I make the change, let me know the effect of that change that I made. And so that's our base look at a process going through not only the part level, but also as we increase the complexity working on the assembly level, Creo Simulation Live can handle all of that. All right, and so again, now that we've seen this process, we can see a little bit more about how we would move forward and work with this tool. So now we have the ability to go through and perform analysis early and often. So it's really lowering our lifecycle costs. We're able to avoid costly recalls along with any type of aftermarket service or repair costs by doing this. We're also reducing the time to market, and that's through the use of our concurrent design and analysis process. Allows us to very quickly and rapidly explore design ideas, instantly identify and resolve any type of design flaws much earlier in the process. That's again saving us from that costly rework. This is allowing us to develop high quality, high performance products that are very easily differentiated in the market. And then through the use of our simulation driven design, we're creating products that perform better, more durable, and most importantly, at a much higher quality. And overall, we're really reducing the product development cost by cutting down the rework, reducing the need for any costly prototypes, and this is all because we're able to get our designs right the first time around. And so that's our look through Creo Simulation Live today. I'll pass it back over to Cassie now. We can talk about some next steps moving forward.
Awesome. Thank you, Paul. Do you have that last slide? You can pull it. Perfect. Okay, I'm not seeing any questions, but I do want everyone to know that we are running a promotion until the end of March. You can get 50% off of these specific Creo extensions with the purchase of a new Creo license. The link to this promotion will be in the email I send this afternoon, along with